All right, welcome everyone. So in today's business world, we're just drowning in data, aren't we? We've got sales figures, marketing costs, operational expenses, everything neatly tucked away in tables and spreadsheets. But here's the critical question. How do we take all these different pieces of information and combine them to uncover the real story? You know, the story that's hiding between the rows and columns? Well, that's exactly where we're going today. We're moving into the realm of advanced matrix operations. And I want to be clear from the start, this is not just abstract mathematics for the sake of it. This is the practical, powerful tool that transforms those simple spreadsheets into actionable business strategy. So let's get right into it.
You know, we all start out with the basics, right? Simple spreadsheets. You've probably built dozens of them already. You've got one column for sales, another for costs, and for simple problems, that's perfectly fine. It's a great starting point. But think for a second about the reality of a modern corporation. What happens when you're not just selling one product, but dozens? And not in one city, but across 10, maybe 20 different regions? And each of those regions has its own unique marketing budget. And your supply chain is a web of 50 different vendors? All of a sudden, that simple spreadsheet just breaks down. It can't show you the whole picture anymore. It's kind of like trying to navigate a massive, complex city, but all you have is a map of a single street. It's useless, right? We need a much, much better map.
Okay, so let's make this tangible. For the rest of this discussion, I want you to put on your manager's hat. Imagine you're working for a company that sells 3 core products. We'll just give them simple names for now: alpha, beta, and gamma. And you're responsible for 3 sales regions: the north, the south, and the east. Now, data is flying at you from every direction: sales reports, expense reports. It's a constant stream. And the big question, the one your boss is always going to ask, is fundamentally simple. Where are we actually making money? Not just revenue, but real, take-home profit.
Okay, so here is our first piece of the puzzle. This is our quarterly sales revenue, represented as a matrix. And as you can see, the rows represent our products, alpha, beta, gamma, and the columns represent our regions, north, south, east. At first glance, this looks pretty good, doesn't it? You might immediately look at, say, product gamma in the east region and see it's pulling in $210,000. Fantastic! And it is so easy to look at a table like this and think, okay, that's our star performer. We know what's working. But this class is the classic trap of what we call a vanity metric. It looks good on the surface, but it's ultimately shallow because it tells us absolutely nothing about what it cost us to earn that money.
And here's the other side of that coin. This is our second matrix, showing the marketing costs associated with generating those sales. Notice, and this is crucial, that it has the exact same structure: products in the rows, regions in the columns. So, for example, we can see that to get that $150,000 in sales for alpha in the north, it cost us $30,000 in marketing. So now we have these 2 perfectly aligned datasets. The million-dollar question, and the entire reason we're here today, is this: what is the most efficient, the most mathematically sound way to combine these 2 matrices to get a true picture of profitability?
Now, this is precisely the kind of multidimensional challenge where our basic tools start to fail us. I mean, sure, you could go through cell by cell with a calculator and figure it out, but what if you had 50 products and 100 regions? It's just not scalable. It's inefficient. This is where we need to level up our mathematical toolkit. We need to stop thinking about individual calculations and start thinking in terms of entire systems. And for that, we turn to the elegance and power of advanced matrix operations. These are the tools specifically designed to handle this very type of complexity.
So when it comes to combining matrices, there are actually several different operations we could choose from. But for our specific problem, think about what we need. We need a direct, one-to-one comparison, right? We want to compare the sales of alpha in the north directly with the costs of alpha in the north. A great way to visualize this is like taking 2 transparent maps and laying one perfectly on top of the other. The operation that does this is called an element-wise operation, and its formal name is the Hadamard product. It is tailor-made for this exact situation, when your matrices are the same size and you want to compare or combine their corresponding parts. Now, we're not trying to model how sales in one region might influence costs in another. That's a much more complex problem for a different tool. For now, we just want to see profit, pure and simple.
So let's formally define this Hadamard product. What exactly is it? Well, its power lies in its simplicity. It has one single, non-negotiable rule that you must never, ever forget. The 2 matrices you are working with must be the exact same size, same number of rows, same number of columns. If that condition is met, the rest is easy. You simply multiply the element in the first row, first column of the first matrix by the element in the first row, first column of the second. Then you move to the first row, second column, and do the same. And you continue this for every single position.
It's a perfect one-to-one matchup that results in a new matrix of the exact same size, where each new element is the product of that direct corresponding interaction.
Now, just for context, I want to briefly show you that other tool I mentioned, the Kronecker product. You'll notice right away it creates a much larger, more complex block matrix. This is an incredibly powerful tool for modeling how every element in one system interacts with every single element in another system. You'll see this a lot in advanced econometrics or quantum physics. For our business problem, it is complete overkill. It's like using a sledgehammer to crack a nut, but I want you to have seen it to know it exists for those more complex interaction models. Okay, with that aside, let's get back to building our profit map.
Okay, that's enough of the theoretical groundwork. The best way to understand these concepts is to see them in action. So let's put this tool to work. We have our sales revenue matrix, we have our marketing cost matrix. Now let's actually perform the operation and build our profit map. Let's see what story these numbers are really trying to tell us. This right here is the moment where mathematics transforms into management insight.
So, the process is incredibly straightforward and logical. We start with our sales revenue matrix. We align it with our marketing cost matrix. Now, here's a very important clarification. The formal Hadamard product specifically refers to element-wise multiplication, but the underlying principle, the element-wise operation, is what we care about. And that can be any operation. Since our goal is to find profit, which is revenue minus cost, we're not going to multiply. We are going to perform an element-wise subtraction. We will take the revenue from alpha in the north and subtract the cost for alpha in the north. Then we'll do the same for alpha in the south, and so on, for every single corresponding cell until we have a brand new matrix that represents net profit.
And voila! Here is the result. This is no longer just two tables of data. This is a strategic profit map. This is the insight we've been working to uncover. And instantly, your eyes should be drawn to the extremes. First, the hero of the story. Product Gamma in the East region, bringing in a clean $160,000 in profit. That's our cash cow. But then, look over here, the problem child. Product Beta in the North, with a profit of only $75,000. Now, as a manager, this single table gives me my entire agenda for the week. For Gamma in the East, the question is, what are they doing so right, and how can we replicate that success elsewhere? And for Beta in the North, the questions are different. Is our marketing spend there completely inefficient? Is our pricing wrong for that market? Or do we have a problem with the local sales team? You see, this one matrix has just focused our entire strategic conversation from vague feelings to specific, data-driven questions.
Okay, this tool is incredibly powerful, but I have to give you a word of caution. It is also completely unforgiving. A small mathematical error here isn't just about losing a few points on an exam. In the real world, a calculation mistake like this can lead to millions of dollars in flawed investments and terrible business decisions. So it is absolutely critical that we understand the rules. Let's talk about the most common pitfalls, the mistakes students and professionals make, so that you can be sure to avoid them.
So let's walk through a very realistic scenario, one that happens all the time in growing businesses. Let's say your company decides to expand. You open up a new West region. The sales department is on the ball. They update their systems, and now you have a new revenue matrix. It's got 3 rows for products, but now it has 4 columns for regions. But the marketing department is lagging behind. Their accounting is a bit slower, and their cost data matrix is still the old one, 3 rows and 3 columns. So you've got a 3x4 revenue matrix and a 3x3 cost matrix. The question is, can you perform that element-wise subtraction to get a quick and dirty profit estimate?
And the answer, class, is an absolute, unequivocal no. You cannot. And this is what I find so elegant about this branch of math. It's not just some arbitrary rule from a textbook. The math is actually reflecting business reality. Think about it. How can you subtract a marketing cost for the West region that you don't even have yet? You can't. The operation is mathematically undefined precisely because it is logically impossible. That dimensional mismatch area your software would give you, that's the math's way of raising a red flag and telling you, hold on, go get the complete data set before you even think about jumping to a conclusion.
Okay, so let's just quickly recap the major errors that I see students make time and time again. First, and this is a big one, confusing element-wise operations with standard matrix multiplication. If you do that, you'll get a result, but it will be meaningless, complete gibberish in this business context. Second, the dimensional mismatch we just discussed. It's the most fundamental rule. You can't break it. Third is using the wrong tool for the job, like trying to use that complex Kronecker product when a simple element-wise subtraction is all you need. And finally, and maybe this is the most dangerous error of all, is misinterpretation. This is where you do all the math perfectly, but you draw the wrong business conclusion from your shiny new profit map.
Remember, the numbers are just the starting point. The true skill of a manager is asking the right questions about what those numbers mean.
So we're nearing the end here, and it's fair to ask the big picture question. Why does any of this really matter? Why are we, in a business administration program, spending so much time on matrix operations? And the answer is simple, because this is modern management. The days of managing by gut feeling alone are over. The ability to handle, combine, and interpret multiple layers of complex data, that's not some niche skill for a data scientist anymore. It is the absolute foundation of every single smart business decision made today.
And believe me, this isn't just academic theory. Think about a global company like Amazon. They are using these exact principles, but at a scale that is almost unimaginable. They're analyzing profitability not just by product and region, but by individual warehouse, by shipping method, by customer demographic. It's a multi-dimensional matrix of staggering complexity. Or think about a major investment bank. They're using these operations to analyze financial risk across different asset classes, different countries, and fluctuating currency values simultaneously. This mathematics, it's the engine running under the hood of all modern finance, supply chain management, and corporate strategy.
And that, everyone, is the ultimate takeaway I want you to leave with today. The goal of this course isn't to turn you all into pure mathematicians. It's to make you into business leaders who speak the language of data fluently. Because when you're not intimidated by the data, when you understand its structure and how to manipulate it, you can ask smarter questions, you can challenge old assumptions, and you can make critical decisions that are grounded in reality, not just in habit or gut feelings. So as you leave today, I want you to think about this. What multi-layered problem, maybe at your own job or in a company you admire, could be clarified and maybe even solved with a simple profit map just like the one we built here today?